Greetings to e-yantra 2019. Our project automatic screw gauge calibrator and component tester. My name is A.B. Parameshwaran from mechatronics engineering, Engineering from Kongu Engineering College. He is Pradeep and he is Praveen and he is Prabhraj, team members of our project. Our mentor's name is V. Arun Kumar. So that's all about us. Main aspect of our project is to calibrate the screw gauge. In in practice, all metrology laboratories used to calibrate the screw gauge and vernier calipers with the help of a manpower, and time consumption for calibration process is also high. Cost effectiveness of the calibration is also high. So we introduced our project to reduce that cost with the help of encoders, and then with the help of Arduino for a certain calculation in the program we included for that. The main motto of our project is to reduce the cost, and for all industries they should buy the calibration instruments without consulting the calibrating industries. In future we upgraded this screw gauge calibrator for the vernier calipers and then also for other process. In our project, prototype includes a screw gauge which is used for the calibration purposes. Then also it includes encoders and motors. Encoders is used to measure the rotation of a screw gauge. It sends a digital value to the Arduino. It's Arduino 2560 we are used. Arduino 2560 for all controller options. Arduino 2560 is programmed as per the calibration process. Then it includes a display, LCD, a 16x2 LCD display which is used to display all the calibration values and also all options that we included in our project. Then it has 3 buttons. In first 2 buttons is used to operate menu, then last button is to reset the value. Then it has a conveyor belt which is used to carry slip gauges in the conveyor. Then it also has a pneumatic and electromagnet. Pneumatic is used to take the slip gauges from the conveyor belt and to the screw gauge. Then electromagnet is used to pick the slip gauges. Then it also used a pneumatic controllers. Pneumatic controllers used to control the motion of the pneumatic. Then it has a relay module. A relay module is used to control the pneumatic and also used to control the electromagnet. Then it has a L29 3D module. L29 3D module is used to roll over the motor and also used to roll over the conveyor belt with the help of digital signals. These digital signals are sent by the Arduino to the L29 3D module. Then the software includes, we used Arduino IDE for the programming the Arduino 2560. The Arduino, the calibration of the software includes Arduino IDE. So the Arduino IDE includes many functions as per the code we sent to you. As the functions includes all the controller values, it is separated by the controllers and also for the calculation actions. So even a simple labor can operate with less knowledge for this calibration process. So I am going to show the demo of our project. So our project includes a 16x2 display. It shows a calibration version 0.1. So it is a first version of our project. So it shows a version 0.1. After the upgradation, it shows a version 0.2. So it includes more options. Then we use 3 buttons which is used to move the menu of our project. First 2 button which is used to move forward and backward of the menu option. Then when we press the forward button, the screw gauge automatically moves to the initial position as 15 mm. So as it's shown. So when it moves to the 15 position, it stops, it shows processing. Then the slip gauge is bring forward to the screw gauge position with the help of a pneumatic. It shows processing. Then we want to reset the option for the internal minus value. Then after that we want to press the next menu. The next menu is pressed to calibrate. After pressing this menu, the screw gauge tends to move forward. When it touches the slip gauge, it stops. Then the calibration process starts internal automatically. When it touches the slip gauge, it shows a calibrating please wait. For the internal options, we include the calibrating please wait option. Then after we press the next menu, it shows a calibration value. It is error 0.82. It means that the value of from the slip gauge and from the screw gauge, the error value is more or less in 0.82. That's all about these options. So by using this option, we want to note the error value of the screw gauge that we used. It uses a knob which is used to remove the slip gauges, remove the screw gauge from this stand, and also replace another screw gauge when we go for the another calibration process. Then the pneumatic supply is given from the compressor with a 2 bar pressure. So for an internal slow process, we uses a 2 bar pressure. Then the conveyor is on when the maximum number of slip gauge is placed in the conveyor. Then it includes Arduino 2560, which is used for these calibration process. When I press the menu backward, it automatically goes to the initial position, and next calibration process is all. So that's all about the demo. In our project, we faced some challenges while implementing our project. First challenges we faced is by taking the slip gauge from the conveyor to the screw gauge. First we use a disc mechanism, so it is not suitable for this method. So that's the first challenge that we faced. So by overcome that, we implemented a pneumatic cylinder for movement of a slip gauge. Then second challenge that we faced is while rotating or while calibrating the screw gauge, the bed of the screw gauge is certainly vibrated. To reduce a vibration, till now it is not to be done and not to be calibrated. So it to be done in 2 to 3 days. So that's the only challenges that we faced while implementing our project. So that's all about it. Completion status of our project. As earlier I mentioned that almost our project is completed, but the vibration of the table is to be eliminated. As earlier I told in challenges that we faced. So the vibration of this table is to be eliminated with the help of some rigid or casting body. So internal errors are occurred while during the calibration. So then the conveyor belt is also to be done. The slip gauges to be placed in the conveyor, and many slip gauges to be placed in the conveyor. So it is more efficient for taking the slip gauges that we want needed. So almost 70 to 80% is completed. Due to internal errors, around 20% is to be completed. So it is all about the completion status of our project. Cost implementation of our project, mainly the major component is Arduino, encoders, and screw gauge is a main component in our project. So it costs more highly. So Arduino costs around 1,300. Then the screw gauge for our project is cost around 3,200. It is branded on a Mitudia one. So the overall cost of our project is around 12,500. So we include more components for a cost reduction. I hope my project is should be selected for finals because it reduces cost and time consumption and also manpower. As earlier I told, in all metrology laboratories, they calibrating the instruments with the help of slip gauges, and manpower for the calibration is also high. So by implementing this project, these to be reduced. As a prototype, we developed the calibration for the screw gauge. As a development, as a next stage, we can calibrate the instruments like screw gauge and also in a vernier caliper by using linear and other type of encoders and digital displays. So the precise for the measurement is also high as we develop to the next stage. Thank you.